Hello everybody, today we are looking at solving trig equations number 3, so it's our third period of this now. And today we want to look at how to solve equations by factorising, so it's something a little bit different from what you have been looking at before. Here is our first example. Now you might notice here you've got a 3 sine squared x at the start. Now we can't treat this like we did yesterday. Obviously yesterday we just square rooted both sides, but that's not going to work today because we've also got a minus 4 sine x. So you have a squared term, you've got a normal sine x term, and you've got a number, so you've got the 3 different things there. These are like trinomials. Okay, we've done these loads and loads and loads. So we need to factorise this into 2 brackets. Now it does look quite complicated the way it is, so my advice would be to write it without the sign in it and just pretend it's just x's until you've got it factorised, and then we can bring the sign back in. Okay? So I've taken out the sign, so I've got 3x squared minus 4x plus 1, and I'm going to factorise that so that I have 2 brackets. So to make 3x squared, I would have to have 3x multiplied by x, so I know that's the start of the brackets. The second sign tells me both brackets have the same sign, and the first sign tells me they're both minuses. I also need 2 numbers that multiply to make 1, so the only way I'm making 1 is 1 times 1. And then I've got it factorised. Now obviously that's not correct because that doesn't have a sign in it, so what I'm going to do at this stage is replace x with sin x, and that would be the factorised version of my original question. At this stage, we're going to split our 2 brackets apart and set each bracket equal to 0 individually, and we end up with 2 trig equations to solve. Now the good thing about these questions is the majority of the time when you get to the solving stage, it is basically just Nat 5 level questions. This is the higher bit where you've got to actually do the factorising. So once the factorising is done, they are quite easy normally. Now one wee thing to point out, again looking at your range of values, so x lies between 0 and 360, so degrees, just make sure you check that before you do the whole question and realise at the end it's radians and not degrees, so it is degrees. So we're going to split them apart. And we're going to rearrange them both until we get sin x equals and everything else is on the right hand side. Both of them will need their own cast diagrams, so we'll talk about that in a little second. I'm actually going to start with the one on the right hand side, the sin x equals 1. Now there's a reason that I haven't bothered to draw a cast diagram for this one. Now you could do it that way, however there's actually an easier way. See if sine or cos is equal to 0 or 1 or negative 1. Okay, so 0, 1 or negative 1. The easiest way to do it is just to sketch it at the side. It will take you 2 seconds. So from that really quick sketch, I know that sine is equal to 1 at 90. It only occurs at one point, so there's not going to be 2 solutions for sin x equals 1. And that's why I didn't draw a cast diagram, I didn't need one for that. For sin x equals 1 over 3, I'm going to do sine inverse of a third, and I'm going to tick my two quadrants. So sine is positive, so A and S, quadrant 1 and quadrant 2. Now this won't be in your exact values table, so this is a calculator question today. And we get our first solution, and then we'll find our second solution, our quadrant 2 solution, by doing 180 minus the 19.5 degrees. I'm going to bring that together at the end and state all of our solutions. So we have the 19.5 and the 160.5 from the first equation, and we've got 90 from the second. Because all of these solutions were for x, they weren't for 2x or 3x or 4x or a half x or anything like that. We don't need any additional solutions, we only have the three solutions that we've got there. Example number 2 is pretty much identical. The only slight differences here, one is the question is in radians this time and not degrees. And 2, instead of using x's, we put in t's, which can make it look a little bit more confusing, but it really is just the same. So the first thing I'm going to do is rewrite that, but without the cos in it, and just have 2t squared minus 3t plus 1, and that will help me factorise it, and then I'll bring the cos back into the question. So to make 2t squared, I know one bracket needs to start with a 2t and the other with a t. Looking at the second sign, which is a plus, tells me both brackets will have the same sign. The first sign there was a negative, so both brackets are negative. And the two numbers need to multiply to make 1, so again it's 1 and 1. I'm then going to rewrite that, but with cos instead. We're now going to split our two brackets apart, set them equal to 0 individually, and then we'll solve. Similar to the last question, I'm going to do the one on the right hand side first, which seems a bit odd, but I know it's an easier one. Again, like I said, if you've got sine or cos and it's equal to 1, 0 or negative 1, you're better just drawing the graph at the side. It only takes a few seconds. So a quick sketch of a cos wave, and you can see that cos of x, or cos of t in this case, is equal to 1 at 2 points. So at 0 and 360 degrees. Now remember this question's in radians, so instead of doing 360 degrees, I'm going to write 2 pi. For the other part of the question, I've got cos of t equals 1/2, so cos is positive, so I'm going to tick quadrant 1 and 4. Cos inverse of a half, well that's one of the solutions that you can get from your exact values table, and that will be pi over 3. That's solution 1, which comes from the first quadrant. So I need the quadrant 4 solution as well, which is typically 360 take away, but again we're in radians, so it'll be 2 pi take away. If you can't do that part in your head, then you're going to change your 2 pi into 6 pi over 3, and you've got 6 pi over 3 take away pi over 3, which will leave you with 5 pi over 3. So that is my 4 solutions from my 2 separate equations. Now we're going to go back up and check one more time at our range. So our values of t can lie between 0 and 2 pi. That also includes 0 and 2 pi, and that's what I was checking there. Had my range been given as t lies strictly between 0 and 2 pi, then that means that t cannot equal 0 or 2 pi, so I'd have to take both of them out of my solutions. But I didn't say that, we have to include 0 and 2 pi. And so all my values of t are 0, pi over 3, 5 pi over 3, or 2 pi. Okay, final example, and this one is to show you something that does happen every now and then that you just need to be aware of. I'm not going to talk through the first bit, you've seen that twice already, so I'll do that quite quickly. I'm going to change my signs of x's just to x to factorise it easily, put my sign back in, and get my 2 trig equations. It's at that point that we need to think about something a bit more carefully with this example. Okay, so now we're at this stage. We're going to rearrange to get sin x on its own on the left hand side equals and get our numbers on the other side. As I have for the previous 2 examples, I'm actually going to do the right hand side equation first, just because it's sin x equals -1, and I've told you if it's 1, -1 or 0, you're better just sketching the graph out. Okay, so that'd be 270, and my answers have to be in degrees for this one. Now let's look at our sin x equals 3 over 2. When you go to do sin inverse, you're going to get up math error. You cannot inverse a number that's greater than 1 for sin or cos. Okay, so if you try and type in sin inverse or cos inverse and the number that you put in there is greater than 1, you're going to get up a math error. Now all you have to do here is say that there are no solutions. Okay, that trig equation cannot be solved. So for this example, there actually is only one solution, 270 degrees. Okay, so if you are doing the questions and you get to a point where you're getting math error, double check your working to make sure it's something you've not done by mistake, but it may be that there's no solutions for that part of the question. Today we're looking at page 63, that's exercise 4H, and you're completing question number 5.